Today the topic is change in base in logarithm. Change in base in logarithm. So when you're working out with this, so let's come up with the question. Let's try to understand this. They have given find the significant value for log 811, right? So we know that if you're supposed to find just like this question, log up, then we get log 2 8. Simply we know that 8 is 2 to the power 3, so the answer is 3. This is pretty simple. If you happen to see log 381 or something, then we can say it's a 81 is 3 to the power 4, so the answer is 4. Those are integer powers. But if you happen to see a question like this, but if you get log 318, we know that 18 is 3 to the power, sorry, it's a multiple of 3, but it's not the power of, it's not an integer power of 3. Therefore, we need to use some kind of a alternative method. That is, we are using this rule. So there is a rule we have already learned in the logarithmic rules. Log AB, you can write is a top, A is B is a top, and A is a base at bottom. You can use a tritary variable XB divided by log XA. That's the simplest rule we have to learn. So for this question, even we can use it, but it's just a common base for most of the terms and most of the tables and calculators. Lot of calculators are supporting this base 10. Therefore, I can write this one as log 10 18 divided by log 10 3. So simply you can get this answer log log 18, it's turned up into 1.2553. 1.2553 divided by log 10 3. Log 10 3 is 0.4771. So with that you can get this answer log 18 divided by log 3. 2.63. This answer become 2.63. That's the answer for that. Okay. Let's go to another question. So as we get, suppose that log 5, we will get 23. We know that 23 is not an integer power of 5. Therefore, I can write this one as log 10 23 divided by log 10 5. So if you can use the calculator and get it, log 23 divided by log 5. It is 1.948. That's the answer for that. That's a way of doing this kind of a question. Let's
1.94.
Yes, 1.948 is the answer for that. Yeah. Then the next part of it. So that is a way of putting this kind of a question. So you can just get it easily. Then we use the same thing to solve a question like this. Log 5x plus 6 times of log x5. 6 times of log x5 is equals to 5. Yeah, it's 5. Then there is another just change in base logarithm. The next logarithmic rule we have already learned is this way. Log AB, you can write 1 over log BA. The facts we have to understand is here this is 5x and this is x5. So this change in variable. So you can use this technique to understand that fact. This is a way of doing it. Then you can write log 5x plus 6 times of 1 over log 5x is equals to 5. Then you can assign, for this is for the convenience of calculation you are doing it today. So we need to find the value for log x anyway. So I just get log 5x, we will get as k. Then it's easy for me to simplify. Let 5k equals to this one. I just write like this. So you can say k plus 6 over k is equals to 5. Then what you need to do is multiply everything with k. Then what do you get with it? K squared plus 6 is equals to 5k. Therefore, you can
5k.
k squared minus 5k
5k plus 6.
equals to 0. Right. Then you can solve this quadratic equation. So you can say this is k minus 2 and k minus 3 equals to 0. With that, you can say k is equals to 2 and k is equals
K
to,
is equal to 3.
yeah. Right. Then what you need to understand is, Pate, here, we need to find not solution for x, we need a solution for k, but we need to find the solutions for x. Therefore, you can write log 5x is equals to 2 is a one equation. Log 5x equals to 3 is another solution. Then you can write x is equals to 5 to the power 2. Log 5x2 is 5 to the power 2. And you can say x is equals to 5 to the power 3. With this, you can write x equals to 25 and x equals to 125. That's a way of getting the solution for this kind of a question. I just minimize this, make it, then you can see the entire stuff at once. That's a way of using different kind of approaches for this one. So these are different questions per day. So one question, and this another question, and this another question, this another one, and this another one, right? Okay, let's go to another question. Let's try to understand how it comes a little bit further. Right, okay. Then, yeah, let's go to this kind of situations. Log 7, 120. So I just do one or couple of questions. Log 7, 120. To answer this question, you can write this is log 10, 120 divided by log 10, 7. Then you can obtain the answer log 120 divided by log 7. The answer is 2.46. Right. Then I'll do another one, so the same kind of questions, this one. Log 2x. Log 2x is equals to 8 plus 9. These are two different questions. Log x 2, right? Okay. Then I'm using the second approach where we were using in previous question. So you can say this is log 2x is equals to 8 plus 9 times of 1 over log 2x. Here this is 2x, this is x2. So you can change the variable by just writing as a reciprocal. Then we will get k, or whatever the letter you can use it, log 2x. Let's turn up to k is equals to 8 plus 9 over k. Then multiply everything with k. Then what do you get? It's turn up to k squared is equals to 8k plus 9. Bring all the terms to one side. The k squared minus 8k plus 9 is equals to 0. From here, you can get the answers for k. You can use a formula to get it, or you can say minus 9 and, sorry. So this is, so if you just minus 9, this is not plus 9, it's minus 9, minus 1. Yeah, plus 1, sorry, it's plus 1. Right. Then k is, you can say, just you gotten this k as log 2x. Log 2x is equals to minus 9. Other one is log 2x is equals to 1. Right. From here, you can say x equals to 2 to the power minus 9. Here the x is equals to 2 to the power 1. So from here, you get the answer x equals to 1 over 512. And here x equals to 2. So that's a way of getting the answer for this kind of question. Right, hope you have understood how to do this kind of situation. So all these questions are just like that, you can solve it, right? Okay. So these are the facts to be learned. So we will go ahead with another question, this much. Over here, they asked you using the substitution of u to the power 2, u equals to 2 to the power x, show that the equation 4 to the power x plus 2x plus 1 minus 15 can be written in form of this, hence solve the equation. Yeah, the equation where we need to solve. If you come across with this, the equation to be solved is this way: 4 to the power, sorry, 4 to the power x plus 2 to the power x plus 1 minus 15 is equals to 0. We need to solve this equation. Now let's see how to do this question. So you can write 4 to the power x. 4, anyway, you have to write with the terms of 2. Pute. Therefore, 4 you can write 2 to the power 2 to the power x. Plus this one you can write 2 in 2 to the power x times of 2 to the power 1. This addition of the powers, you can write it as a multiplication. Equals to 0. Then this is turned out to 2 to the power 2x plus 2 times of 2 to the power x. It's a isolated term minus 15. In last lesson, we will learn how to do this kind of a question. So you can write this is 2 to the power x all things squared plus 2 times of 2 to the power x minus 15 is equals to 0. So we get let 2 to the power x equals to k, that is k squared plus 2k minus 15 is equals to 0. So with that you can write k plus 5 k minus 3 is equals to 0. So here you get the answer k equals to minus 5 and the answer is k equals to 3. So we get the k, we gotten the k as 2 to the power x. 2 to the power x is minus 5, other one is 2 to the power x is 3. So let's do this question. Let's take the logarithm 10 for both sides. Log 10 minus 5. So you can say x times of log 10 2 is equals to log 10 minus 5. So this is does not exist. So you can understand that you cannot get a negative logarithm for negative answer. So this won't be there. So we have to proceed from here. The base of the use of taking logarithm of base 10 is that's a common base where it's most of the table and calculators are designed. That is the purpose of getting log 10 today. Therefore, you can say x equals to log 10 3 divided by log 10 2. So from here you can get this answer. 1.585.
1.585.
Yeah, that's a way of getting this answer. Okay, right. That's a way of doing this. Right. Okay. Yeah. Yes. Let's see how to solve this kind of a question with it. I think we need to learn this kind of situations. Suppose that if you want to get log 2x minus log 2x plus 1 is equals to 3. Initially, what you need to do is, using the logarithmic rules, we have to simplify this. Then you can say this is log 2x. This is a division, you can write it as x plus 1.
X
X
plus 1.
plus 1 is equals to 3. Then we know that if this is log 2, some expression equals to 3 means you can say x over x plus 1 is equals to 2 to the power 3. That's a fact we are learning in our previous theory. So you can say x is equals to 8 times of x plus 1 by just first multiplying with that. So you can say x equals to 8x plus 1, sorry, plus 8. Therefore, you can say 7x equals to minus 8, x become minus 8 over 7. That's a way of getting this answer. Okay, right, that's how it comes. Right. Let's go to another question. Suppose that we get a question like this. Log 2 log 3 x plus 1 is equals to 1 plus log 3 x minus 1. Right. Okay, let's see how to do this kind of question. Initially, take all logarithm terms to one side. Then you can say 2 log 3 x plus 1 minus log 3 x minus 1 is equals to 1. Then simplify. So what you can do here is log 3. These two you can take in as a power.
Yes. Power.
This subtraction you can write it as a division.
Division.
Is equals to 1. So with that you can say x plus 1 squared over x minus 1 is equals to 3 to the power 1. Then we can simplify this. If you just get into this one, you can say x squared plus 2x plus 1, just the expansion of this, and it's equals to 3 times of x minus 1, the cross multiply with this. So we can say x squared plus 2x plus 1 is equals to 3x minus, if you bring to the other side, x squared minus x plus 4. I don't think this is existing, but
Yes, sir. Answer is like,
real answers won't exist. Ne?
yeah.
So you can say no solutions exist because you cannot get any answers for this much. This is just a randomly generated question. Right. Okay, let's go to another one and see. So this way. So you can say log 3 x plus 1 is equals to 2 plus 2 log 3 x minus 1. Right. Okay, let's go ahead with this. Same technique we use. So you can say log 3 x plus 1 minus 2 times of log 3 x minus 1 is equals to 2. Then you can write this is log 3, this is x plus 1, and this minus you can write as a division. If you take it in, it's turn up to x minus 1 squared is equals to 2. So you can say this is log 3 x plus 1 over x squared
9.
minus 2x plus 1 is equals to 2. So from this way you can say x plus 1 over x squared minus 2x plus 1 is equals to 3 to the power 2. So you can write x plus 1 is equal to 9 times of this factor. X squared minus 2x plus 1. So it's turn up to 9x squared minus 18x plus 9 minus x minus 1. I just brought this term to other side. And it's form a quadratic equation. So if you simplify this, it's turn up to 9x squared minus 19x plus 8 is equals to 0. From here, you can get the answer is equals to minus 19 is plus 19. You can use the formula plus or minus b squared, 19 squared. 19 squared is 281. Sorry, 261. Sorry, 361 minus 4a is 9, c is 8, divide by 2 into 9. From here, you can get the answers for x. That's a way of doing this. It's 9 and minus 19.
So 19 plus square root 73 over 80.
Yeah, that's great. Okay. So if you just write it like this, you can say it's 0.58 is a one solution. Other solution is 1.53.
1, no, 1.53.